Okay, am I on? All right, hello everyone. So there's been a lot of progress made, everyone here in this room, advancements in materials and technology, in demonstrators, and project call, collaboration, doing a lot of great things. But at the same time, not a lot of high volume commercial impact, in terms of real commercial impact. So I've got some insights on that, but first just a little bit about me. So when I was a kid, around 14 years old, I started working in my family factory. And I still remember having my paper time card in the time card machine, cha-chunk, and like a stamp of my time in and out, which was nice because I knew I was getting paid. But the excitement, though, of just being in that factory environment and seeing the innovation and the fast-paced production work and things getting made and people working as a team and a family vibe, that was exciting. In and out of engineering school, hired on to a Fortune 500 Cooper Industries as a manufacturing engineer. I shuttled down to Georgia, and I'm working in my first project. I'm tooling. I'm making designing a fixture to support a tooling in a manufacturing work cell. I think the drawings are perfect. The drawings go out to the factory, out to the maintenance shop, and I'm immediately humbled, because they're supposed to fabricate my design. I'm immediately humbled when I find out they completely changed my design and made it actually work so that it could be put in production, right? So that was me, extremely naive, overconfident, thinking, not really understanding that you could have a great idea, but the reality of that idea in an actual application environment might be completely different. So I think the lesson for me at that time was pretty enlightening. So in this talk, I'm going to try to glean on that a little bit, share some insights, go from there. So I guess if you're going to remember anything that I say today, it would be that great technology, you can have great technology, but that does not equate to a great commercial success. So I'm going to share some insights from Tapecon, some of the projects that we've worked on with everybody here. So story number one, it's kind of three different stories. Story number one, 2019, a company called G-Clip. We find this company, G-Clip. Early stage company, not a lot of technical expertise, not a lot of fundraising at the time, not a lot of market adoption in their product. And they're working on a smart insole, force sensing resistor insole shoe for competitive rowing, for crew. We didn't really do a lot of force sensing resistors at the time, so we actually referred them out to a friendly competitor of ours that we knew, and they had a lot more force sensing resisting experience. Fast forward, 2024, they come back, and they still needed some more design assistance. We didn't really feel like we could provide that type of level design in the beginning. We actually sent them over to Nextflex. They did an engagement with Nextflex. And then eventually we referred them out to a company in Europe who specializes in product development for insole shoes. They've now got them almost to a complete proof of concept. They're working on a app and the data management strategy for the shoe. The fundraising has started to pick back up. Prototyping is coming close. Market adoption coming, and they've said that when they're ready for high volume production, they're going to come back to Tapecon and we're going to start to be their manufacturing partner. So I share that story because technology can only take you so far, but the ecosystem matters. There's more to it than just the technology. Where's the right partner at the right time for the stage of where that early stage venture is. Story number two. This story is a little bit about things not really going as we expected them at Tapecon. So just north of our location, there was R.R. Donnelley had a printed electronics business unit. That was eventually shuttered and closed. We caught word of that in the Buffalo area. And I knew that within that R.R. Donnelley facility, they had a roll-to-roll FHE line where they were doing some pretty innovative things way ahead of its time. So we brought our lead FHE engineer at the time, we brought our operations team, looked at the asset, said, this is great. We're going to bring this in, and in months, we're going to be running high throughput, roll-to-roll FHE. Didn't happen. That didn't happen the way that we expected. So the machine comes in, and we ran into a few challenges. Number one, it was an older machine, and really this was a bunch of different machines integrated. We ran into web tension control problems. We ran into old, outdated software, old, outdated drives. We realized that we did not bring in a competent, high-throughput, roll-to-roll machine that was ready to go. What we brought in was a highly customized, tightly integrated machine that had some challenges. At the same time, the commercial opportunities that were coming to us at Tapecon were not high-volume, high-throughput quantity demands. They were actually low to medium volume quantity demands. Some of our life sciences leads were looking for clinical trial type volumes, hundreds, maybe thousands, that's it. So between those signals from the market and the challenges with the machine, we decided to pivot towards a sheeted version of this machine. And now we have, and we already have roll-to-roll converting capability. We do roll-to-roll, roll-to-sheet, sheet-to-sheet. So we knew we could learn that even if we had something in a sheet format, there's ways we can put it back into a roll, whether that's through lamination or island placement in some of our roll-to-roll pieces of equipment. So that pivot was done. I think the lesson there is have market strategy lead equipment selection, not the other way around. And I think that's that lesson. Story number 3 is kind of a story around problem-solving mindset, I would say. So historically at Tapecon in the late 80s, early 90s, we really got our start printed electronics for large surface area geometries for membrane switch keypads, not very dense circuits. And we had traditionally used isotropic conductive adhesive to lay down those types of passive components. And all fine and dandy until we start getting involved in this ecosystem and we're challenging ourselves for denser circuits, finer pitches, and we ran into a challenge. We ran into bridging. Now, what we originally started to do was what we know, which is, well, we know ICA. Let's optimize, let's work on better screen printing or stencil. Let's try to tune process parameters and make it work. But we really weren't getting anywhere. We were up against the walls of physics. And so the pivot, or the epiphany, I guess, taking a step back and thinking there's got to be something else we're missing. Enter anisotropic conductive adhesive. Enter thermal compression bonding unit. And now we're starting to get some traction. And if I go back to my first story, we didn't do it in a vacuum. We reached out to our ecosystem partners, asked questions, learned, got a lot of great insight from people in this community, and made our way through. And now ACA, we have a repeatable process. We're going to build a sheets-based work cell, and there's validation underway, and there's progress. So I guess the lesson is not getting so stuck on one particular path, taking a step back, looking at a different approach. So the best I could come up with was to make FHE the best, think est. Kind of catchy, I don't know. Ecosystem, strategy, technology, the right partners, the right strategic path, and the right approach to technology, which is how I think we can have more commercial impact in the FHE ecosystem, but also kind of how Tapecon's trying to have impact as well. We're a contract manufacturer, so at the end of the day, we sell technical capability, but I like to think we're selling technical capability, but we're really selling commercial readiness for our customers. We're allowing our customers to launch their applications with our commercial readiness enabling that. And you need the ecosystem, the strategy, and the technology, and that has to be paired with a commercially viable product. Otherwise, there is no commercial impact. So all those things have to be in place, plus a commercially viable product. And I will say that we're trying to do that by making sure that we're designing for manufacturability up front. We're picking applications that FHE will win at, that FHE is going to be a winning recipe. We're picking projects that are going to recur in revenue for us. And we're not just trying to work on projects just to prove that it works. We're trying to work on projects that we prove that it works, we can deliver it we can produce it at a high throughput scale, and then deliver it at a high volume scale. So that's the end of my talk. Look forward to connecting with everyone in this ecosystem, because this is an ecosystem. Marcus from our engineers here, who's working on some of the project call. Brad Hall is over here helping us with our strategic approach too. So there's 3 Tapeconians here in the room to engage with the rest of this ecosystem. Thank you. I don't know how I was on time. Okay.